7.3 is all about solving trigonometric equations. So we're going to put together everything we've learned so far about trigonometry. The unit circle, sine, cosine, tangent, and also a lot of our algebra concepts like factoring, solving equations. We're going to put all of that together to start solving trigonometric equations. So what we're going to do is work backwards on the unit circle, just like with inverse sine and inverse tangent, inverse cosine. You want to work backwards. So if you look at this basic example, sine x equals 1/2. That means find all the values of x where the sine value is 1/2. So if you recall from our unit circle, sine is your y coordinate. So you want to think everywhere on the unit circle that has a y value of 1/2. And so that is all the pi over 6's. And we have a positive 1/2. So y is positive in the first and second quadrants. So x is going to be pi over 6. And it's also going to be 5 pi over 6. However, there's no restriction on this domain. X can go on and on and on forever, just like the sine function graph. So if they don't give you an interval to give an answer for, then you would write x is pi over 6 plus or minus every 2 pi, every full circle. So 2k pi. And x also equals 5 pi over 6 plus or minus every iteration of 2k pi. And so that is how you solve these equations. You're going to be looking for solving for x so that if you plugged it back in, it would fit the equation. Of course, they're not always going to be that easy. Sometimes you're going to have to isolate the x or isolate sine, cosine, or tangent before you start solving. And so this is where I would recommend you start taking notes so that you have this to refer back to and you have some examples to look at when you're doing your homework. When we've got solving, just like when you're solving for x in regular algebra, you first have to isolate what you're solving for. So I need to get sine by itself. So I'm going to add 1 to both sides. So I have 2 sine x equals 1. And then I'm going to divide by 2. So sine x equals 1/2. Now I can solve for x. However, in this problem, I have an interval over which to solve. And I'm going to make that a parentheses right there. So now I only want all the x values between 0 and 2 pi that satisfy this equation. So it makes it a little easier. So I'm looking for any radian value where the y coordinate is 1/2 because sine is the y coordinate. So just like that example above, x can be pi over 6 and x can be 5 pi over 6. And we're done. Let's look at another example. This one has sine on the left side of the equal sign and sine on the right side of the equal sign. So first you need to get all the variables to one side. I'm going to add sine x to both sides. On the left side, we've got sine x plus sine x, that's 2 sine x plus root 2 equals, now we have 0. Now I can isolate sine. I'm going to subtract root 2 from both sides. So I have 2 sine x equals negative root 2 and divide by 2. So now I'm looking for all the radian values on the unit circle where the y coordinate is negative root 2 over 2. And knowing the unit circle very well is going to help you in this section. Root 2 over 2, that's all the pi over 4s on the unit circle, and it's negative root 2 over 2, so that's going to be down there in quadrants 3 and 4. So that means x equals, that's pi over 4, 3 pi over 4, 5 pi over 4. And 7 pi over 4. And so there you have your two solutions between 0 and 2 pi that satisfy this equation. Feel free to pause anywhere in this video to catch up, take notes. go rewind and watch the example again. I'm just going to keep on going through this video, and you pause and rewind as much as you need to. Sorry if I give you motion sickness. Scrolling down. Let's look at another one. Now we've got tangent and a squared term. You might be tempted to use some of your knowledge from 7.2 and your Pythagorean identities, but you actually don't have to do that here for these basic equations. When we get to the complicated ones, you might, but for this one, we're still just going to isolate tangent just like we did the first two examples. I'm going to add 1 to both sides. So I have 3 tangent squared x equals 1. Divide by 3. And now to get rid of a square, you can take the square root. And whenever you square root both sides in an equation, do not forget to put a plus or minus. Plus or minus, square root of 1 is 1, and then over root 3. If I rationalize that, I have plus or minus root 3 over 3. I taught you guys a trick, if you remember from the last chapter, of how to remember tangent. All the pi over 6's is root 3 over 3. And all of the pi over 3's is just root 3. So the way you can remember that is 3 plus 3 is 6, and then that's just a 3. And then, of course, tangent of pi over 4, all the pi over 4's is 1. So that's, I recommend you memorizing that. It's going to make your life a whole lot easier when you're doing these equations with tangent. Now, because of the plus or minus, that means we can be in all 4 quadrants. So you're actually going to have 4 answers for this. So root 3 over 3, that's all the pi over 6's. So we're going to say x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that's your answer right there. Let's take a look at another example here. Now we have cosine squared. So I'm going to add 3 to both sides. I've got 4 cosine squared equals 3. And now I'm going to divide by 4. Cosine squared is 3/4. Left out the x there. Square root both sides. And do not forget, every time you square root both sides, you have to have a plus or minus. Plus or minus root 3 over 2, because the square root of 4 is 2. So again, because of that plus or minus, we can go with all 4 quadrants. So we want to look for what radian values on the unit circle have an x-coordinate of root 3 over 2, because cosine is all of your x-coordinates, and that is all the pi over 6's. So again, we've got pi over 6 as our answer. I'm not doing that on purpose. 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are your answers. So hopefully you're getting the hang of this. These are the basic equations, and I want to go over a couple more that require factoring. So I know you thought factoring was over last semester, but now we're going to start factoring with trig. And it's not as scary as it sounds. So sometimes there's an equation that's already factored, like this one, and you solve it the exact same way you would if you had something like x plus 3 times x minus 4 equals 0. You just set each factor equal to 0 and solve each one. You're going to do the same exact process as you would for this, for tangent and cosine. So it's already factored, so I'm going to set tangent x minus 1 equals 0 and cosine x plus 1 equals 0. So I'm going to add 1 to both sides. Tangent x equals 1. And we already figured out that tangent equals 1 at all the pi over 4's. And this is going to be positive. So tangent is positive in the first quadrant and in the third quadrant, because you've got positive divided by positive and negative divided by a negative. So x could be pi over 4 or 5 pi over 4. There's 2 of my answers. And then I can solve this other equation with cosine. Cosine x equals -1. There's only one value on the unit circle that has a cosine of -1, and that is at pi. So this has 3 answers to it. That one was nice because they already factored it for you, and you just set each factor equal to 0. It's not always going to be that easy. Like the next example, we've got cotangent x, cosine squared x minus 2 cotangent x equals 0. This one's not factored yet. So remember, just like all factoring with anything, always look for a common factor first. And then if it's a trinomial, you can actually factor it with the table. But this one's only a binomial, so I'm going to look for a common factor. I notice they both have a cotangent, so I can factor out a cotangent. Cotangent x, and then what would be left over is cosine squared x minus 2, like that, equals 0. And then I've got cotangent x equals 0. And I've got cosine squared x minus 2 equals 0. And now I can set this one equal to 0. Cotangent x equals 0 at whenever 0 is in the numerator. So remember, cotangent is x over y. So everywhere there's an x coordinate of 0, that's where cotangent is 0. So that's going to be at pi over 2 and 3 pi over 2. Now let's take a look at cosine squared x minus 2 equals 0. I'm going to first add 2 to both sides, and now I can take the square root to get rid of the square. Oh, I didn't mean to do a highlighter. Let me write that better. Take the square root of both sides, so now I have cosine x equals plus or minus root 2. This is where it gets a little tricky, and you have to really be thinking about what you're solving. Cosine values of any radians can only be between -1 and 1. If the value is greater than 1, then it's not on the unit circle. Square root of 2 is bigger than 1. There is nowhere on the unit circle that has an x-coordinate bigger than 1, because the largest your unit circle can go is 1. The radius is 1, so the biggest x-coordinate you can have is 1. So this one's actually not solvable, so there's no solution here. So these are your only answers right here, pi over 2 and 3 pi over 2. I'm going to show you one more example, and then we'll be done with the basic trig equations, and on Monday we'll start factoring some more and solving some higher level equations here once you've practiced these over the weekend. This one, first thing we have to do is get all the variables to one side. I'm going to subtract 2 sine x from both sides. I cannot combine these because one of them is squared and one of them is not. So I'm just going to write them next to each other. Sine squared x minus 2 sine x equals 0. Now I can look for a common factor. I notice they both have a sine in them. So I'm going to factor out a sine x, and then I'm left with sine x minus 2. And it's factored form, so I can set each factor equal to 0. Sine x minus 2 equals 0. This first one already has sine by itself, so what values of the radians on the unit circle have a y-coordinate of 0? And that is going to be at 0 and pi. Technically, you could say 2 pi as well, but if you remember from the instructions, I only wanted it over the interval bracket 0 to 2 pi parentheses, so don't include 2 pi. So there's 2 of my answers. Then the second one, I'm going to add 2 to both sides. Sine x equals 2. Same problem we had in the last example. there's nowhere in the unit circle where a sign value is going to be 2. The largest it can be is 1. So that is out, and these are our only answers right here. So again, I know I went a little bit fast here, but I did that with the intention that you would pause, rewind, and rewatch any pieces that you need to. And hopefully you took notes so you have these examples to look back on while you practice.